Many people are asking about Merlin and its suitability for use in humans. Merlin is a veterinary ventilator designed back in 1997. It has many features and it may be used for humans. It has the capability, but I think I produced this video so that anybody interested or concerned about the use of Merlin for humans can watch this video and come to that answer and make their own decision from this information. To give it a bit of background, Merlin has been in production since 1997. It's had a few changes in that time, but it remains basically the same. But Merlin is basically an efficient syringe pump, driving a precision syringe with a very accurate motor. If I remove the lid, then we can have a look inside the machine and we can see how Merlin works. All the patient driving pressure is created by this pump, which is a big piston inside this cylinder acting like a big syringe. There's no need for a separate driving pressure. There's no requirement for a oxygen high pressure line to drive this ventilator. The motor here drives the pump, and the valves here control the airflow of gas to the patient. All the parts that are in contact with the patient are made of either stainless steel, anodized aluminium or silicon, so the whole machine can be readily disinfected for decontamination between different patients. There's a viral and bacterial filter here which protects the chamber from contamination. In the event of contamination or use in patients with known transmissible respiratory infections, the whole machine can easily be disinfected, and this viral filter and communicating pipes can be discarded, replaced with new, and the machine quickly returned to use. The whole procedure to do that takes about 30 to 45 minutes. We'll now have a look at how to use Merlin. Merlin is a volume support ventilator and can be pressure cycled or volume cycled. It can be run in a rebreathing or non-rebreathing configuration. It can have PEEP and assist modes. In its simplest form, with volume cycling and non-rebreathing configuration, I believe this is the most likely configuration for humans with COVID-19 infections. So here's the setup. Gas from the anaesthetic machine over here is delivered to Merlin at low pressure into the gas in port. Merlin doesn't control the gas input, it simply expects gas at low pressure when it wants to fill the piston again. So this is not the traditional input from a high pressure 60 psi 4-bar oxygen outlet. This is coming from a low pressure typically from an anaesthesia machine or from a flow meter outlet. Equally, Merlin will be very happy to just pull in room air. So if you remove the gas to the gas in port, it'll pull in room air. If we put a bacterial filter on there, we can ventilate patients on 21% of oxygen. If we put a blender, we can feed in air and oxygen and receive blended values between 21% and 100%. What is the bag for on the anaesthesia machine? The bag there is for to act as a reservoir for incoming gases and to make the use of Merlin fresh gas efficient. The gas input here is periodically closed during the inspiratory phase so that any incoming gas cannot enter the machine. During that period, the gas will collect into the reservoir bag and Merlin will use that to refill in the next expiratory phase when it's filling the piston again. What this means is that Merlin can actually exactly match the fresh gas flow requirement to its own minute volume requirement. And when the two are matched, that's the perfect efficiency for running a non-rebreathing circuit. The reservoir bag needs to be about double the capacity of Merlin, so about 2 litres. If the fresh gas flow exceeds the minute volume requirement, the excess gas is vented by the APL or adjustable pressure limit valve. In non-rebreathing mode, waste gas is simply directed to the scavenge system from the gas output. As you can see here, we have a PEEP valve attached on the gas output so that we can achieve any value of PEEP that we require. We will come back to that. So, a note about the mains failure or the condition of the machine in the presence of a mains failure. All the valves will fail open so that the configuration of the circuit remains unchanged. So if this is connected as a rebreathing circuit using the circle, then the circle connection is retained and the animal can still breathe spontaneously using the circle. And the same applies to a non-rebreathing circuit. And in both instances, the bag in that anaesthetic circuit can be used for manual IPPV. So the machine fails safe. Okay, let's set Merlin up for volume cycling and to ventilate a patient for about 300 mils tidal volume. In this instance, our patient here is Rover, an animal simulator which has a lung capacity of about 300 mils. We've been running on a non-rebreathing circuit from an anaesthetic machine with the gas flow fed into the gas in. We haven't got anything on the gas out, but that would be straight to scavenge. For the patient connection, we have 2 patient and from patient, and we have a one-way valve in the 2-patient limb. We'll come back to that later. Okay, to set up for volume cycling is very simple. We simply work from left to right on the control knobs. The first one is the volume control, so we set that to 300. Second one is inspiratory time, we set that to 1 second as our default inspiratory time. And we've got a 2-second expiratory time for a respiratory rate of 20 as shown on the screen and an IE ratio of 1 to 2. Our maximum pressure in the airways has been set at 25, so if the pressure reaches that value, the inspiration phase will stop and all the expiratory valves and inspiratory valves will open, immediately reducing the pressure. At the moment, we're not going to use the assist mode, so the assist threshold is blanked off and we're actually ready to go. So all we need to do in this instance is put the ventilate mode to run, and we see that Rover is indeed ventilated. Okay, so on the machine we have the inspiratory pressure on the bar graph, and we have the expiratory limb pressure on the bar graph, which at the moment are the same. In the presence of PEEP, then the expiratory pressure will show a different reading from the inspiratory pressure. Okay, if we look at the screen, we see the information that's available. So we see we have a total volume of 300 mils. That was what we set on the dial, so we would expect that. So a minute volume of 6 litres as derived from a respiratory rate of 20 and a tidal volume of 300. Our airway pressure is going up to a peak inspiratory pressure of 20 as the first value, and after the slash we have 0, and this would indicate the peak value. At the moment there is no peak, so this is 0. Our IE ratio is 1 to 2, and the compliance is measured, in other words the dynamic compliance of the patient is coming out at 15, so it's 15 mils per centimetre of water pressure. And as I said, the respiratory rate is set to 20. So simply, that's it. That's how you set up volume cycling, and those are the results you get, and the machine will continue to do this for as long as required. In testing, all our machines run for 7 days solid, continuous testing, and they obviously will run longer, but testing is all done at 7 days. Right, so what we can do now is change to pressure cycling mode and see if we can emulate what we've got here just by changing the approach, but aiming to achieve the same result. I'm just going to stop the machine. So we had a maximum airway pressure of 20, so we're going to make this our target for pressure cycling, so we're going to change this to 20. In the pressure cycling mode, we don't know the inspiratory time because that'll be dictated by how long it takes to get to pressure, so we're going to turn this run right round so it says PL. Now we're in pressure cycling mode. The knob you probably saw on the left here was saying mils, and as soon as we went to pressure cycling mode it changed to flow. So there we are in mils. As soon as we get around here, now we're in pressure cycling mode. So we've got in flow rate for our control. So we'll set this to 18 litres. So we'll be delivering 300 mils in 1 second. So on the basis that 6 litres a minute is 100 mils per second, 18 litres a minute is 300 mils per second. So we should, with these settings, achieve our aim of delivering about 300 mils to our patient. So we put this to run. So we can see now that the airway pressure reaches 20, that's our target. So volume is delivered, or flow is sent into the patient until it reaches 20 centimetres of pressure, and then it stops. The measured volume is 311, very close to what we had previously. And our minute volume is based on the total volume and respiratory rate as before. Our compliance is also still 15. We've now achieved the same ventilation parameters as we had before. So in this instance, what happens if we restrict the patient's chest? So we'll do what we did before, restrict the patient's chest. So because we're pressure cycling, the airway pressure still doesn't go above 20 as our target pressure, but of course the delivered volume is now reduced because the pressure is reached much sooner. So now we're only delivering a tidal volume of 217, 213 mils. As a consequence, our minute volume is reduced and our inspiratory expiratory ratio has gone to 1 to 2.2. And our compliance has also dropped because we have a less elastic lung. We would remove the restriction and go back to the situation we were in before. And now I want to look at the assist mode function and ability of Merlin. This is a simple assist mechanism that's triggered by a negative pressure in the patient airway. So when the assist mode is set to on, it's possible to set a trigger threshold in centimetres of water between -8 and -1 centimetre of water. So -1 centimetre of water trigger threshold is very low, and even a small tiny breath, tiny inspiratory effort would be sufficient to trigger this. As the patient gets stronger, for example weaning from an anaesthetic or for weaning from a ventilator, increasing the assist threshold changes the effort required to trigger the breath. When the breath is triggered, the full breath is delivered to the specifications and parameters already set up. So if you're pressure cycling, it'll deliver the breath to a pressure. If you're volume cycling, it'll deliver the breath to a volume. I'm just going to run this and show you the effect of setting the assist mode to on. So this was our volume mode setup that we had before, 300 mils tidal volume and a respiratory rate of 20. I'm just going to change the expiratory rate to 18 just to demonstrate the effect. So there we have a respiratory rate of 18, a minute volume of 5.4 litres, and I'm going to put the assist mode to on. Two things have happened. One is the ventilator has now stopped at the beginning of its inspiratory stroke, waiting for the patient to make an inspiratory effort. The other thing that has happened is that the respiratory rate and the minute volume have been reduced to 1/3 of their previous values. What this means is, in assist mode, that Merlin will default to 1/3 of the mandatory minute volume that was in effect before. And if the patient does take a breath, the initiated breath will then reset the timing for the mandatory breath. So in other words, with a respiratory rate of 6, we have 10 seconds between breaths. If there's no patient effort, as what's occurring in the background, every 10 seconds we get a beep and the breath is given by the ventilator. If, however, the patient were able to take a breath and trigger the breath, then the interval between the start of that and the next mandatory breath would be reset to 10 seconds. Now Rover can't take a breath, so I'm going to just disconnect Rover and simulate the breath myself by drawing in on the inspiratory airway. I'm going to change the threshold to -8 just so we can see on the screen more clearly the effect. Just wait for the next breath. Okay, so now I'm going to breathe in and we'll see the airway pressure on the screen. The airway pressure was shown to go through -1, 2, 3 down to -7, and when it reached -8, the breath was triggered. That was a mandatory breath. And these are all triggered breaths by myself. So you can see how easy it is to go between the assist mode and non-assist mode just by changing the assist mode button to on and off. The next thing to look at is the ability to use PEEP on the Merlin machine. This is easy to do using our own custom PEEP valve, which is a stainless steel construction and connects very simply to the gas out port. by pushing onto that port. And the knob here at the top will control the amount of PEEP we're going to set. It's easier to demonstrate the effect of PEEP using pressure cycling mode. Only easier for the demonstration. It makes no difference to the PEEP in use on the machine at all, but for the purpose of the demonstration I'm going to put this to pressure cycling mode. So if we go to a flow rate of 9 litres a minute and we have a target pressure of 15 centimetres. Okay, we'll set this running. Okay, fairly modest ventilation, target pressure of 15, and we see we have just 1 centimetre of PEEP there from the PEEP valve. Now I'm going to very slowly wind in the PEEP control. And you should see PEEP developing on the screen as shown by the bar graph here as well, and the absolute value is shown as a number on the screen. As I increase the PEEP, this value will continue to rise. Okay, I'm going to increase the maximum pressure now so that we have a bit more of a threshold above the PEEP value. So you see now that we have on the expiratory limb bar graph a non-return to zero indicating the PEEP. The actual value is shown on the screen. And on the inspiratory side, we obviously have a return to zero because we have no retained pressure there. Okay, I can increase or decrease this PEEP value up to, our standard valve goes up to 25 centimetres of PEEP and down to 1 or 2 centimetres. However, we can make PEEP valves to almost any specification. So I've turned up the target pressure and I'm just increasing the PEEP just to demonstrate the effect. Okay, so now we have 18 centimetres of PEEP. And this of course can be used in conjunction with the assist mode, which I've just put on. So now we have our PEEP value there. And it behaves in exactly the same way whether we have the assist mode on or off. This concludes the demonstration of Merlin. I hope this has shown the ease of which Merlin can be adapted to volume or pressure cycling mode and the simplicity of use, yet with its versatility with assist and PEEP modes, it lends itself to ventilating a number of patients in different configurations and setups. I hope this has been useful. Please refer to any other information on our website or contact us directly if you have any further questions. Thank you.